In this video, we're going to be simplifying radicals. In this first example, we're just trying to look at reducing what's underneath the root. Now, there's a few ways to look at it. Now, 27 is 3 cubed. And 3 cubed is the same as 3 squared times 3. Same with the x cubed. X cubed is x squared times x. And y to the 8th would be y to the 4th squared. And I'm looking at powers of 2 because it's a square root. So this 3 squared I can bring out as a 3. Square root of 3 squared is 3. This x squared can come out as an x. And this here, y to the 4th squared, would be y to the 4th, leaving me underneath a 3 and an x. Now, same idea for the second example, but it is a 4th root. So now we're going to look at powers of 4. Now, 64 is 2 to the 6th. So now let's break things down by powers of 4. So 2 to the 6th is the same as 2 to the 4th times 2 squared. The x cubed, we really can't do much with this because 3 is less than 4. Y to the 7th is the same as y to the 4th, y cubed. And z to the 8th would be z squared times 4, or to the power of 4. So now we can take out this 2 to the 4th, giving us a 2. We can take out this y to the 4th, giving us a y. And we take out this z squared. And then underneath the root, we still have a 2 squared, which is 4, an x cubed, and a y cubed. When adding and subtracting roots, we try and reduce what's underneath the root. 48x is the same as 16 times 3x. 75 is the same as 25 times 3x. We know we are on the right track because both of them have a 3x. From there, we can break it up to root 16, root 3x, plus root 25, root 3x. Root 16 and root 25 simplify. We have 4 root 3x plus 5 root 3x. Now we can collect like terms, giving us 9 root 3x. Now the second example is something you'll see quite often. We want to rationalize the denominator. We don't like that root in the denominator. Okay, this is the same as root 3x over root 2. And if we multiply both top and bottom by root 2, this will give us root 6x over root 2 squared, or root 4, or just 2. Now, here's a few more examples of working with rationalizing denominators. This example, we have a cube root, and it's the same as cube root 3x over cube root 2y. But I can't just multiply by cube root 2y. This won't be enough. So what I'm going to do is multiply by cube root 4y squared. And I have to multiply the top by the same. Now I'm choosing 4y squared because 2 times 4 is 8. Cube root 8 is 2. So you look at powers of 3. Y times y squared is y cubed, so cube root of y cubed will just be y. So let's multiply. We get cube root 3 times 4 is 12, and then x times y squared. In the bottom, we will have cube root of 8y cubed, which, as we said earlier, simplifies to just 2y in the denominator. Now the next example, we can factor y squared out of each term. We now have root y squared times root 3 over 2, 1 plus a half. Square root of y squared is just y. Root 3 over root 2, as we showed earlier, is just root 3 over root 2. We're going to times both by root 2 over root 2. So we end up with y root 6 over 2. Now let's look at a few examples of multiplying and dividing functions with roots. This first example is a very simple one. We just have a bunch of roots multiplied together. So we have 2x times 3x times 6, which is just 36x squared. Root 36 is just 6, root x squared is just x. So a nice simple one. The second one though, we're going to use FOIL. So we multiply the first two, so 6 root x squared. The outside, 10 root 2xy. The inside, so minus 3 root 2xy. And then the last, negative 5, 4y squared. Start simplifying. Root x squared is just x. We can collect the two middle terms, so we end up with 7 times 2xy under the root. And then the last term, root 4 is 2, and root y squared is y. Simplify the last term a little bit further. And we get our final answer. Dividing roots is the same idea. We can divide the 16 by 2, which is 8. The x to the 5th by x, which is x to the 4th. Now cube root 8 is 2. Cube root x to the 4th, well, x to the 4th is the same as x cubed times x, so we can take one x out, and we're left with one x underneath the cube root. Now the last example here is a little bit more complicated. We're going to multiply both top and bottom by 1 plus root x. And we're choosing 1 plus root x because it is a conjugate of the denominator. So just switch the sign, and this will eliminate roots in the denominator. So on the top we get 2 plus 2 root x plus root x plus root x squared. In the denominator we get 1 plus root x minus root x minus root x squared. Simplify, we get 2 plus 3 root x plus x over 1 minus x. So as you can see, there's now no more roots in the denominator.